On today's video, I've traveled all the way up to Alaska. I'm gonna be here with Josh, who's a fourth generation miner. He's gonna take us underground, show us some of the workings, and then we're gonna check out the original mill that his grandfather used to mill 1 ton per hour, 24 hours a day for 4 years. We're just about to head into the underground workings, but we're gonna talk a little bit about the geology, and there's a couple of faults here on the valley floor. So Josh, tell us a little bit about the mine here.
So the mine was originally started way down the mountain at the 200, and you can kind of see how the hillside was going up, but then they had a huge throw that way. So when they were following it on the 200, they ended up losing the vein. And so the mine that we're about to go in is a development of them trying to find the vein.
Cool.
Back from the big fault.
Yeah. And this is where the miners, in this beautiful Alaska weather we're having, it's hard to see everything we're talking about, but we're in this big valley bottom here, and there's a big fault running right up through the valley. And the fault has offset this vein in a couple different places. So in the 20s and 30s, the original miners worked this section of the vein and then stopped. And then Josh's great grandfather came in the late 30s and early 40s and worked the lower section of the vein underneath that original stope. So we'll go see all that, but this faulting has caused a lot of problems for these original miners because it's really hard to follow when you're stoping up and following a vein, and then all of a sudden, boom, it's gone, and you got to go look for it and find it, and then you're stoping again. So faulting is really a problem in some of these narrow quartz veins because you just don't know where it goes. We're headed up to Compressor House to look at some of the old equipment. And you had some friends come up and built this. Helped you build it?
Yes. Yep. The hoe barrier is what we call it. The hydraulic, just to help clean out some of the muck.
Okay.
Yeah. So most of the mine was actually hand mucked.
Okay.
And we ended up getting tired of that, so they decided to build a hoe barrier, is what we call it.
Okay.
And it really helped a lot with getting some of that muck out after a blast.
Nice. That's pretty cool. Good old Joy over there.
We're about to head into the portal, and on the east side where the original workings are, it's pretty darn rich, and there's some really good veins going on. Once you get across this north-south trending fault onto the west side, the vein is not as rich, and so a lot of the workings are going to be over here on the east side, and that's where the original stope is, and that's where Josh's great-grandfather's stope is. We're going to go in here on what they call the zero level, and we're going to go down to long winds into the old workings. So it's really important to engineer your portal in a way that it stays open, because that was the death throes of a lot of these mines, is the portal would cave in, and then you're doing a lot of work trying to keep it open and from sliding in and big rocks coming down. This is a beautiful portal. They've got concrete that comes out about 20 or 30 feet from the rock face. They've got a good lid on it, so it protects it from anything sloughing off the hillside in the winter. Let's go in and take a look here. It's just a beautiful, beautiful spot. They got the rail. It's dewatering really nice. And once we get in here, we can talk a little bit more about the geology, but this is a quartz diorite. So it's a volcanic intrusive rock. This is a huge batholith that came up. This magma came up and cooled under the surface. It's been eroded away, and now the miners have come in, and as that magma came up, it brought with it a bunch of fluid that brought the gold and the other minerals up with it. So the quartz diorite is the material that brought the fluids up, and the miners found a lot of the rich veins in this quartz diorite. All right, Josh, we're walking back in here. As we're walking, can you talk a little bit about, this was done in the 20s or 30s?
So this mine shaft was actually done not that long ago. It probably started in like the 80s.
Oh, this is something your dad did.
This is the shaft that my grandpa, my dad, and a few friends drove. But it connects to a raise that the miners from the 30s drove to vent out the mine.
Oh, I see. So that your dad and grandpa did this to connect with the old workings.
Yeah, yeah.
I see. But this is all driven through waste. There's no ore in here. It was just to access.
Just a crosscut, yeah. But they did hit a vein right here. This is the first vein that they hit.
Oh, nice. So talk a little bit about this and what, this is very typical for the district, huh?
Yep, this side is about average. It's not a very big vein district, but it sure is rich in some spots. Unfortunately, this vein didn't end up running very good, so they decided, well, this might have been just another stringer that we just made our way through. So we're just gonna keep driving to maybe find that other vein.
Was this a blind vein that they didn't know was here and they just stumbled across it driving this drift?
Yeah, so yeah, their map actually ended up, the vein was hitting a little bit farther deeper than mine, which there is a vein that they hit farther deeper than mine.
Okay.
But this is not the main one that they were going for. But they obviously drifted in both directions on it.
Did a little development on it. So this was just a happy surprise on their way in, huh?
Yep, exactly. Yep.
Nice. Did they have it assayed? Is there any gold in it?
Very little.
Very little,
Yeah,
okay.
Not enough to make a profit.
Okay.
Yeah.
But in a lot of these veins, your dad was telling me last night that even though it's barren here, 100 feet on strike, these veins can develop into some pretty nice little pocket stopes.
Yep. If they keep driving on it, and you can see that a lot going through the older workings of the mine. That when you follow it and it's stringer, it's not very rich, and then it opens up and it gets nice and rich, and that's where you can see all the stopes and winzes driven on those areas. But with sometimes it's just worth chasing down the vein to find the better stopes.
So they kept driving here to intersect a vein that they did know about.
Yes.
Okay, so they the originally planned vein. So they hit that little stringer as a bonus, but they wanted to work down here. This is a lot of work, man. So this is the vein they were projected to hit, which obviously hit it. And again, Josh, it's not very wide here.
No.
But did they develop it much and get some?
They developed. They ran quite a drift going that way, and you can see this little bit of stoping that we did up here.
Yeah.
But it just didn't end up panning out to what they were expecting, which was that like 5-ounce original gold cord vein.
And this is the original vein that the old timers worked at depth.
Yes.
Okay, and they were going to come in and work it up.
Yes.
But it pinched and didn't have the grade.
It didn't end up working out.
Got it. Okay. Cool. The first vein they hit has the same strike and dip. So there's this vein and that vein are kind of in parallel with each other. Is that really common for this district where they're just kind of laying on top of each other?
No. So a lot of veins they end up crossing something.
Yeah.
And that's usually where a lot of the miners would like follow, right on that drift, right along where those two veins cross. But I bet you if you would have followed one of these veins down, I bet they would cross at some point.
And intersect. And at that intersection point, typically it's really rich.
It's thicker and
Yeah, awesome.
So we just did a blast over here not that long ago, and we had the mucking machine, and we had our little skid steer in here mucking it out.
Oh, cool. When you say not too long ago, how long is not too long ago?
About 2 weeks or so.
2 weeks?
2 weeks ago.
Wow.
You were in here working 2 weeks ago?
Yeah.
Oh, cool. That's awesome.
Fired up the compressor and back to it.
Cool.
Nice.
So you've got your little, what is this, 9-12B or something? 12B, what do they call them? It's a little mucker. It's a little air mucker. This is rad. And so you blast on the face,
Yes.
and this is the muck pile,
Yes.
and you got bored of mucking.
Yeah.
You're like, this isn't good right now. This isn't good. Maybe do something else. Oh, cool. And so you were developing this vein looking for a pocket.
Just wanted to keep driving, one blast a year, see if it ever turns into something, but more just for fun.
One blast a year.
Yeah,
I love it.
Just a blast a year.
Just a blast a year.
Uh-huh.
And when you're drilling, you're doing jack leg,
Yes.
and you're doing 6 or 8 foot rounds?
6 foot rounds. Yeah.
6 foot rounds.
6 foot
Okay.
rounds.
So
But
you've got-
sometimes we do 5, just
Yeah.
keep it simple.
Yeah. Cool. You shoot it. You come in with your little mucker here. It comes in, scoops up on the pile, over the top of your head, right?
Yep.
Well, not your head, but you're standing on the side, but goes over the top and into the ore car.
Yep.
And then out you go into the dump.
Out you go with the ore car. Yep.
Yeah. Way better than hand mucking.
Yeah.
Harry, we should take note of this.
Yes, I have jealousy. I want this machine.
This is cool. There's not a lot of these working anymore. You see them in museums all the time, or like mining museums.
Yeah.
But this one's running.
Oh, these are good units. These will save you a long time.
Yeah.
All right.
Taking water.
There's your bucket.
There's a little muck bucket.
How much weight does that bucket hold? Like 300 pounds or
Yeah, not
200 pounds, something like that?
Maybe, yeah.
Yeah, that's awesome. So you guys definitely hit some water here.
Yeah. That's making a lot of water just flowing out. We've had hard rain the last couple of weeks.
Yeah. Yeah.
So you're just following this little slip here.
Yeah.
There's not really even ore. You're just following the structure, hoping that it develops into something, huh?
Right. Well, it's pitches so tiny that you can't really tell that there is much of a vein, but it's storage vein, so you then keep following.
Yeah. And hoping it develops into a nice little pocket.
Right. Yeah.
Awesome. And here's our winds going down to the original workings, huh?
Yeah.
And so these workings, the original workings were farther down the valley, and they came this way.
Yes.
Which
they portaled in farther.
Which is west, right? We're west of the original opening.
Yes.
Okay. And who?
Oh no, sorry. We're east.
We're east of them.
Northeast.
And so who developed this raise or winds? What is that? Your grandpa or your dad?
So the old timers, they ran a raise up here to vent some of their fumes out.
Oh, I see. This goes all the way to the surface.
Yeah.
Oh, I get it. And so this was done in the 30s.
Yes.
And you guys just drifted in to intercept this to get access.
Yeah, just to get access to the lower parts.
Oh, I get it. And how far down does this go? 130 steps or something.
130 steps. Yeah.
So 130 feet, roughly.
About. Yeah.
Dang. All right. Well, let's climb down. Here's Harry coming down the last couple rungs. Josh, I've been in a few raises, not a lot, but that is a beautiful raise. Like the ladders are in great shape. You're using the original timbers to anchor the ladders to. And for those of you at home watching, 130 feet may not sound like a lot, but that's a long climb down. That's a long way to go.
That's a lot of work. Yeah.
That's a lot of work. And as you're climbing down, we mentioned that this goes up 130 feet to where they intersected it with the drift, but the raise goes up another 200 feet to the surface. And they drove this just for development, for getting air down to vent out the lower workings of the mine.
Yeah.
A lot of work.
Yeah, because it dead ends this direction. And the portal is out that way. So they needed some way to, because it would take them so long to vent out the fumes to the down that fume.
Did they run vent bag down here, or was it just natural ventilation? It helped vent.
I can feel it a little bit.
Yeah.
They're moving. We're under the valley floor now, so they couldn't access the surface going that way.
Right.
Yeah, so they had to come up and go through the hard rock.
Right.
Yeah. And these workings, did your grandpa do these, or these were the original workings?
So this is the 100 level workings. So this is the original workings before my great-grandfather.
Or your great-grandfather, yeah.
Yeah, before he was in the district.
So this was done in the 20s.
Yeah.
Kind of thing.
Yes.
And we're not on vein now?
No.
Okay, this is just a little bit development work.
There you go. And this was a raise my great-grandfather drove up to get water to flow down through his 200 level, and also to, because they follow a vein going up this way. So,
Okay.
and to send rock down.
So
Grizzly right there.
Yeah.
your grandfather put this raise down. on vein.
Yes.
Is that what you just said?
Yes.
And does this go up to the surface?
No. So that just follows the vein up.
Just follows the vein up.
Yeah. You can see a little bit right over there in the back.
Yep, right there.
So very rich.
It's narrow but rich.
Narrow but very rich, yeah.
How rich are we talking? Multi-ounce.
Multi-ounce.
Yeah.
Yeah.
Dozens of ounces?
In spot.
In spot.
But yeah, very rich but thin.
Very rich but thin. Cool.
So I think he drove, my great grandpa I know drove raised from the 200 level up to this.
Oh, I see. He came up from the bottom
Yeah.
all the way to intersect. Okay, cool. So here's another little raise connecting the 100 from the 200. And this is not the one we're going to go down.
No.
But your grandfather, great-grandfather, worked connecting the levels. And so on the 100 level, which we're on, this is where the good continuous vein was.
Yes.
That they did a lot of nice continuous stoping and produced like 10,000 ounces or something, right?
Yeah.
And then your great-grandfather came in and was like, well, let's go down dip and we'll find more of this awesome vein, but it was all cut up and faulted and screwed up.
Yeah, it was hard to follow, yep.
So we'll get down to the 200 level
Yep.
and check that out.
Yep.
Coming through again, this was a ore chute where they built them out of wood, and there's probably some workings up here. They'd send ore down to this ore chute. They have tracks. They could pull a cart right under, pull whatever ore they wanted into the cart, and then out towards the surface to the mill. But you see a lot of these in these old mines. These are really engineering feat. Getting all this wood and all this stuff to where you've got tons and tons of rock sitting on your ore bin here, your ore chute. You got to pull a cart underneath. You got to lift this up, get the muck to flow, and then be able to stop it just at the right time. There's a lot of engineering and luck and art that goes into making these things. It's really, really impressive.
Well, you can see way up there too. And they were using the old school little, just the little knife gates there.
Yeah.
I forgot the term for those, but that's a swamper's job. You know, you can meter the flow with those two into your cart and you get just the right amount, and then down the track you go.
And make sure that you can stop it. And also, you want to make sure it doesn't plug up there. Because if it plugs, then you got a real problem. 'Cause
Yeah.
if you climb up there and it lets loose, you get squashed.
Yeah, it's a suicide mission.
It's the suicide mission for the guys. This is really, really cool, seeing all this old stuff in place. And it's just like they left it. Like they walked away in the 20s, and I mean, there's still ore in it.
Yeah.
So we came across this full of water, and it's perfectly clear. How deep would you say? Oh, it's like what, 15, 20 feet down?
Yeah.
Yeah, probably, yeah.
That is really cool.
The old sump.
There's like something growing on the bottom of the logs there.
Yeah.
That's the kind of stuff I like seeing.
Josh, how many hundreds or thousands of feet of workings are in the gold cord?
And the gold cord was probably 1 or 2 miles of more work.
1 or 2 miles. That's a lot of work.
Yeah, a lot of work.
Yeah.
Yeah.
Those old guys are tough.
Yeah.
Here we come up on a second ore bin and chute.
So look here, they were stoping here.
Oh wow.
So they jobbed it all up with timbers. But look here at the footwall, you can see
Wow.
the vein.
Nice.
Look at that nice cord.
Nice big vein.
Yeah. And it looks, I'm guessing here, but it looks like the top of the vein was running and the bottom was waste.
Yeah.
So they just took the pay of the vein.
Took the pay, yeah, nothing.
But this is where you were talking earlier about these veins. We followed this drift for a couple hundred feet, and the vein was like inches, very, very narrow, and then it just blossomed into this huge area, and they started stoping, and this is how they would just follow these slips along, and they develop into these big open stopes, or big open veins that they could stope on, and they could make enough tons to where it was profitable for them.
Yeah, this thing's starting to belly out a little bit. There's got to be a lot of tonnage sitting on top of this lumber.
Yeah.
Yeah. Just keep moving.
Yeah, let's get out of here. I
Yeah.
don't want to stand here too long.
Yeah, these are those places you don't want to. I mean, once they mine it, you know, you get out.
Yeah, right.
You know, they didn't intend on coming back to this, so they just put it in place just long enough for them to get it out, See how it looks? We already had a failure over here.
Right.
Wow.
Another.
Oh yeah, look up there, Harry.
There's-
You can see the ladder
There's a manway way up there.
all the way up in the stope. I don't see any pillars. I see a bunch of stalls. That's very cool. Is this the main stope on the 100 level?
Yes.
Yeah, okay.
Yep. This is the main stuff.
And they stoped this way quite a ways.
Yes.
Okay, so we're going under all this good stuff.
Right.
All right, well, there's a rope tied onto the old airline there. So we're gonna work our way down this, I don't know, I would call this a winze because it's going down, but
Yeah.
your great-grandfather put it in as a raise. So it's really, it really depends on which way you're looking. So a little mining terminology here. A winze is when they worked down on the vein at an angle typically. And a raise is when they were underneath coming up. And so this would have been a winze if they worked down, but it sounds like his great-grandfather worked up on it. So we're gonna call it a raise. But we're gonna crawl down this raise. How far is it?
Oh, shoot, 100 feet?
100 feet.
Yeah.
So it's a 100 level, 200 level.
Yeah.
And this is, now we're getting into your great-grandfather's workings.
Yes.
Okay, let's go see what he did. You want me to stick close with you again like the ladder? Or you want me to just let you go?
No, yeah, I think keeping it close is probably the way to go.
Okay, cool. So we'll go down close, Harry, and then when we're down, we'll holler up to you.
Roger.
Does that work?
Yes, sir.
Just like the old boys. And typically on these old raises, you needed about 45 or 50 degrees for the muck to run down. If they were any shallower than that, you'd blast and the muck would sit there. So this 45 degrees is about as shallow as you can go to keep the muck running. But you can still pretty much get up and down and not too bad. Yeah, we're on the 200 level right now. A little later, we're gonna go down to the mill and check out where they milled the ore. But this level we're on ends up coming out on the surface right at the mill. And your great-grandfather was in here from I think your dad was saying 38 to 42 or something like that. Right when the Second World War shut down all the mining, it put this whole thing to bed. Haven't been in here since, right? Other than your little screwing around at the top.
Yep, no active mining here since 42, yep.
But your dad's big vision is to get the portal cleaned out at the 200 level and get back in and access all these workings, get the mill going again, and turn this back into a producing mine. Awesome. We're on the 200 level, and this is a great exposure showing the vein that they were following. It's a narrow, coarse vein, maybe 1.5 feet wide. Really good showing of the granodiorite host rock on both sides. And this is just a beautiful showing. This vein could be averaging up to what, about 1 ounce or 1.5 ounces a ton?
Yeah.
Is kind of what the average grade they were working?
Yes, yeah.
So really, really rich. I'm looking here for sulfides. There's not a whole lot. It's a pretty darn clean vein, but there's a few little pyrite cubes in there, it looks like. I don't see a lot of sulfides, which is exactly what those old miners wanted. They wanted quartz and they wanted gold, which made the milling really, really easy. You didn't have a bunch of gold locked up in the sulfide values. So this is like a miner's dream right here. The only thing that could make it better is if it was 4 feet wide instead of 1.5 feet. But I bet there's some spots here later that we're gonna see that were wider.
Well, yeah, so sometimes they would prefer a thinner vein because usually when they pinch, they get a lot more rich than when they really swell.
Oh, is that right?
Yeah, so then there's less rock to mill, so it's not as cost, it's not as much cost to mill it because there's less vein, and so usually when they are thin veins like this, they would send this directly to the mill.
Oh, so they get excited when it was a thinner vein.
Yeah, thinner vein, but usually when it was 1 foot like that, it's super nice, easy to stope, and it was nice and rich. Yep.
There was something I heard the other day that a couple of guys were talking about, your dad being one of them, about the theory that the amount of gold in the vein is the same whether it's 3 or 4 foot wide or 1 foot wide. And so that kind of goes with what you're saying in this district, like when they pinch down, you're at 3 or 4 ounces a ton. Mm-hmm. And when it goes to 3 or 4 feet wide, you're down to 1 ounce a ton.
Yep.
Because the amount of gold is the same, but the vein's gotten way wide.
It's just the volume.
It's
Yep.
just the volume.
Mm-hmm.
So cool. This is a great showing of the vein. And they were just drifting along on vein until they found a spot they liked, whatever the criteria was, and then boom, they started stoping up on your great-grandfather would stope up to the old workings.
Yep, exactly.
This is such an awesome showing. These are great workings.
Yeah.
Yeah, so I can't keep my hands off this vein, and I'm really fascinated by some of these bands of sulfides. It looks like either pyrrhotite or pyrite, but in my vein back home, when you start seeing these bands of sulfides right along here, is where we would start seeing some nice free gold showing. And what we saw on the surface yesterday is when you would find these bands, these little black pockets, is where you start seeing little flecks of gold. So this could be a really good indication that this section of the vein right here, not the whole thing, but just this section, is a really rich spot.
Justin, what are you saying about the stringers?
Yeah, in this district, it's really common to have your bulk part of the vein lower than the stringers. There would always be these little stringers that were above the main part of the vein, and I'm not sure why that was, but even if you go over into the other workings at the other mines, you can find similar kind of vein structure where there's the main part, but then there's also the stringers above, and they would stope it all and send it all.
What kind of grades were they getting in those stringers? Were they like higher grade or kind of similar to the, you know, the main bulk of the vein?
You know, when they would split off from the vein, they wouldn't be as rich as the stringers would, but they were still worth doing. So they took the effort.
Yeah, I mean, they already did the work to get here. Why wouldn't you?
Right, might as well, you know.
This is a pretty cool shot, Harry. Here, you can actually see right here is the fault, and there's some gouge right there. See that gooey gray stuff? So that's right here is the slip where you had the movement, and then on the hanging wall, it doesn't look like there's any mineralization at all. All the mineralization happened on the from the hanging wall. Why they call it the hanging wall? But from here down, you start getting these little stringers below the fault, and you had a little stringer here, a little stringer here, maybe a little one here, and then boom, you get the main vein, and there may be a few underneath as well. Yeah. But all the mineralization happened underneath the fault, which is really cool. Here's one of the stopes that your great-grandfather did. What was his name?
His name was Anson Levick.
His what?
Anson Levick.
Anson. So Anson did this in the 30s and 40s.
Yep.
And you can see, I don't know if you can see on the rib over here, the fault. There might be the vein you can see underneath there. It's a little bit hard to see from this angle, but they just worked right up. Had a nice little timbered up chute here, and they sent the ore down to the 200 level here, and then out to the mill. How far? It's hundreds of feet, maybe 1,000 feet or more to the mill from here.
Yeah, it could be.
It's a long way, yeah.
Long way.
So there was a long haul to the mill, and this is something that you and your dad are really excited about opening up in the future.
Yep, absolutely. That's definitely the dream.
Yeah. You know, we're seeing the vein here. There's a little stope here. There's still lots of ore between the 200 and the 100 that you can just come and mine.
Absolutely.
Yeah.
Lots of pay left.
Lots of pay left. That's what we want. Lots of pay.
Always mind the gouge.
Take the gouge. Yeah.
Take the gouge. Yep. Absolutely.
And you might be having, you know, the hanging wall here and the footwall here, something, and this is your vein structure.
All pay. Yep.
Yeah.
Send all it through to the vein.
So that you're looking at your future work here.
Absolutely. Yeah.
This is going to be your project.
Absolutely. Yeah.
Yeah, pretty well defined footwall here. Some gouge on the footwall, gouge on the hanging wall. The veins all chewed up in here, so there's probably some. Once the vein was emplaced in this structure, it looks like there's been some movement post emplacement. So it's all ravelly and broken up, which is not uncommon. And sometimes you'll get multiple generations of emplacement. So the first generation comes in, maybe with or without gold. The fault moves, brecciates it all up, and then you get a second round of emplacement, and that can happen a bunch of different times. And sometimes you can get different minerals in place. So the gold will come in, and then later the sulfides will come in, or vice versa. So the geology of these underground workings can be really complicated just for the vein mineralogy, but then you add in faulting, offset faults, and pinching and swelling, and I mean these old timers were, and they were blind. Every round was a new adventure, so they didn't know what they were going to get into or how they were going to work it. And so they just followed it along, and when it was good, they stoped it, and when it wasn't, they kept going, hoping it would develop into something. And when the money ran out or the war came or whatever, they stopped. It's really kind of that simple. I mean, you can talk about, you know, the history of a lot of the mines out west, and that story right there can be applied to almost all of them.
There's a pretty clean slip. I was looking at the back above you. There's a nice little potato chip right above your head, just barely hanging.
This guy?
Yeah.
Yeah. The other thing you can see here, let's see if I can show it, is what's called slicken sides.
Yeah.
And I think if you maybe use your imagination, you can see some.
It looks like it was kind of slipping vertical, right?
Yeah. So you see some where the slicken sides are where the rocks rub against each other, they leave like scratch marks. And so here you can kind of see, it looks like it was, all the movement was this way, because they're going up and down in this situation.
Remember Dale was talking about you can kind of run your fingers on it and feel kind of which way it was going. If you go against kind of the direction it was going, you kind of feel it was kind of grabbing, and then the other side, the way it was actually going was smooth.
Yeah, here's some really good indicators of movement. Up and down. You kind of shine your light 90 degrees to it, and you can see the little shadows showing the direction.
That's cool.
But it's really, it's super soft. It's just clay in the gouge in this situation, or in this vein.
Back when my dad was a kid, him and my grandpa pumped out the 300 and 400 level, and no one had been there since 42 because they quit pumping out to keep following the vein down. So when they pumped all the water out, they seen my great grandfather that used to always walk kind of like that, and so like a duck, exactly. And so when they went down there, all they could see is a bunch of duck footprints walking up and down the track.
Oh, no way.
Yeah, so it was like you could tell no one had been there
Since 42?
Since 42.
And your grandfather was the last one to walk
Exactly,
in and out?
walked in and out and
then it flooded.
flooded up from there.
So you were literally walking in or your dad was literally walking in his grandfather's footsteps.
Exactly, yeah.
That's cool.
I know. Yeah.
That's a cool story. Yeah, because I mean, and you talked about it over in the mine next door. Like when the war, I don't know, the war bill or whatever, it shut all these mines down. Like the miners, they walked out.
Yeah.
And they never came back.
Right.
So like their tools, sometimes you'll find like, you know, all kinds of crazy stuff. Like they were coming right back, and it never happened.
Yeah, everything was there. Yeah, it wasn't scavenged or anything. It's just like they were here one day and gone the next day.
Yeah.
It's really fascinating.
Literally frozen in time.
Exactly.
Yeah, cool. We've been following this drift for hundreds of feet, and we've been on strike, following along, following the structure of the vein, and all of a sudden this thing takes a 90-degree turn, and what's happened is we've intersected one of these faults, like I was talking about earlier in the video on the surface. The veins got faulted off, so the miners are going, uh-oh, we got to go look for it somewhere. So I think they've taken this 90-degree turn, and their hope, I don't know what's back here, but their hope is that it's gone like this. And so we've been drifting this way, and now we're turning 90, and they're on the other side of the fault, hoping to intersect the vein, figuring that this block was down dropped, and that they're going to intersect it. So let's cross our fingers that they found it on the other side of this fault.
In this district, though, like the rule of thumb would be to, if you lose it to a fault, go down into the east.
Down into
So
the
this
east.
is probably, I guess, eastward.
Okay. So there's a regional movement that all these faults move on,
Right.
and the veins drop to the east.
Yep, that's just the basic rule.
Okay.
It's down into the east.
Well, let's cross our fingers that that's the rule here, and they intersected again.
Yeah.
But I think we came, what, 20 or 30 feet down or offset, and they've intersected the structure again. You can see it here underneath. They raised up on it here, so they chose wisely and they went the right way.
But it almost looks like they lose it again because of the big turn.
Yeah, then they turn again here.
And these poor miners.
I know, it's hard, it's hard.
That would be hard.
And this is like, for everybody at home, going 50 feet through waste, not knowing where you're going, is a huge project. It's not like, oh, well, let's just do this on the weekend. This is like, weeks of work.
Yeah.
And you're drilling and blasting. They had jack legs and air. They weren't hand steeling this.
Yeah.
But still, I mean, you had to hand muck it, you had to get it out of the mine, and you had to come in, do another 6 feet. So this is a huge, I mean, it's a big gamble.
Well, and, in today's money, it'd be like a couple $100 a foot, it's expensive.
Yeah. So you're talking about $5, $10, $15, $20,000
Yeah.
of no pay and a gamble. This is literally like rolling the dice and being like, I hope we hit it. So that's what these miners were faced with every day.
What'd you find?
I don't know, we got like a prehistoric fin hoe here. It's not quite the shape I'm used to, but it's a shovel bent over. It's a little muck rake thing. They could rake the muck in.
Yeah, those old miners use what they had.
Oh yeah, use what they had and fixed it when it broke.
Right.
Oh yeah, here we go.
Also, they did find it.
Boom, we got vein.
Yeah, so they picked it up.
Yeah, look at that. That's actually really, that looks good.
That is.
Yeah, so they hit this little turn and they picked it up again.
Yeah. Your dad was in here tripping on it or something, open it up.
That's it in there, yeah.
But yeah, this looks great. Surprised this didn't get stoped on. Yeah.
Maybe that's what this little deal is right here. They went up, maybe tried to get above it and see how big it was.
Yeah.
Because that was pretty narrow back up there.
Yeah, well, yeah, a vein down here. So you got 2 or 3 feet of pay here.
Yeah.
Or vein, anyway. I don't know if it's pay. But... Hey, we got a little stope.
I like it.
So that's a good sign.
Yeah.
Boy, look at how narrow the footwall and the hang wall is great.
Oh, must have sucked to work that.
But once you get up there, it just pinches down. But it must have been paying pretty good for them to chase it.
Sure.
Yeah, that's a good sign though. That they did some stoping. Timbers, bunch of muck back there.
Is it face out over here? Or? Nope, still goes.
Keep going. Whoa, look at this. Yeah, a lot of quartz. Yep. And then more quartz here. Like the vein dives a little bit.
Looks like it did.
Yeah, it looks like they faulted the vein stripe changes or something. Yeah. Because they were off in here.
Oh yeah, this is it. The rail's starting to end. I like how they turn the rail on the side like this. When they're bringing the mucker in, they'll go ahead and drill and blast, and then they'll bring the mucker in. And before they stand the track, they'll lay them on the side like this so they can get in there and muck, and then they'll pull it back out of the way. And when they get enough distance, the guys will come in and stand the rail up and then keep going.
Yeah, this is it. They were out.
Faulted off, yeah.
Must have faulted off on them.
And it was original.
So Josh, I've been joking with you about, you're going to spend the rest of your life in here working and stoping these veins, but there's a lot of other veins on the properties you have here. And where in your opinion is the spot that you want to work?
In my opinion, it would be awesome to go and mine these old workings that my grandpa did, or my great grandpa. But it's not the best vein. It's faulty and it's not as rich. It's not as structurally solid as the other veins. But if I was to pick one, I'd pick it's the new vein that me and Aaron are working on. There's been no development on it, and the outcrop is looking promising.
So you would develop a whole new set of workings.
Yeah.
Yeah, awesome.
New portal in it, yeah.
That's like the dream too. I think like a lot of miners, we're like, yeah, these old workings are cool, but I want my own mine. I want to do my own thing.
Absolutely.
Yeah.
Absolutely.
Yeah, that's cool.
The thing with these old mines, like it's possible and it's good to remine them and keep developing, but a lot of these old timers are good. Like they sampled and they took all the rock that they could, and they didn't want to move any more rock than they had to. So a lot of the rock that they left, they usually left for good reason. But there's always chances to keep developing, and maybe it'll open up.
Sure. Yeah. Sure. Well, I'll give you my little 30-second spiel on like what ore is. Right.
Yeah.
Back in the teens and 20s, gold was $20 an ounce. Then it went to 35 in the 30s and 40s. So all of a sudden, like stuff that wasn't valuable became valuable, and now gold's $2,500 an ounce roughly.
Right.
And so if gold goes to $5,000 an ounce, all of a sudden all the stuff they left is like, oh yeah, we could actually mine that at a profit.
All of a sudden it's all profitable.
And so yeah, so the term, the definition of ore is something that you can mine at a profit. And so the ore is constantly changing in your workings depending on what the price is and what the cost to get it out is and what the cost of materials is. So even though this may not be ore now, in the future, 5, 10, 15 years, this could be ore. But then just like you're talking about, there are better paying ores on the property.
Right.
So you would have to get the other stuff going first because that's where you can make more money.
Well, yeah, and there's also the fact of what is easy. You know, what will be the least amount of effort and money into to start developing and start, you know, getting paid. So like with something like this, the rule of thumb was 0.75. If it's less than that, leave it. But like at today's price, 0.75 is very, you know, that's manageable to mill that and make a profit.
That's a good grade. Yeah.
Mm-hmm.
Yeah. 3/4 of an ounce is a good grade.
Yeah, absolutely.
And yeah, like you're talking about, easy. Like the stuff that, you know, you mentioned the AJ vein, like it may be running 2 ounces a ton, but do you have to put $2 million to like get there, access it, develop it?
Right.
Whereas this is running 3/4, but you just got to dig the portal out, do a little rehab, and all of a sudden you're mining 3/4 of an ounce. So
right.
There's all these factors that go into what make a mine profitable, and it's not just the richest spots.
Right.
There's a lot of factors that go into this underground mining.
Absolutely.
That can make it worth it or break your pick. So something to consider if you're going to open your own gold mine. I wanted to show you a map and get you a little bit oriented about where we were. We came in on the 0 level, which is not on this map. Climbed down the air raise and came out here on the 100 level. Came here, we intersected the vein, and we came across this way. I think we saw this stope here. Kept going. Then we came back and came down this raise or winze down to the 200 level. We looked off this way, it was flooded. This continued down to the 300 level, but it was also flooded. And so we went out this way, and a lot of what we explored is not on this map because it was done after this map was made. But we came way out here past the fault and wandered way out over here. But I wanted to show you, if we would have gone this way, gone through the deep water, we would have gone into the workings. And look at the amount of workings. The old stopes, this is the 100 level stopes. There's some 200 level stopes and 300 level stopes. It's a huge amount of underground workings that we never even saw, never even really got close to. But if you follow the 200 level all the way along, the 200 level comes all the way out this way, out to the mill. So there is a massive amount of workings in this underground mine. Very cool. We're back on the surface. Up here behind us is the 100-foot level. So this was done in the 20s and 30s. They came out here. You can see some of their old dump piles. Al's been up here working, getting a road, trying to get it accessible. But they came down here with their ore out of the 100 level. And I'll turn around here, and Josh is going to walk us through their old mill building. This is collapsed now.
Yes.
But Josh, this is where they milled all their ore from the 100 level.
Yep, this is the old gold cord mill, and they had a trestle coming from up there, from the dump pile, all the way over and into their mill building. It's a tiered setup, and it was they had a stamp mill going down through it. But yeah, we could go check it out.
Yeah, I'll follow you. So what they had their mill building here.
Yes.
They had a primary jaw crusher crushing it, and then down into a stamp mill.
Down into the stamp mill, yep. And then over the amalgamation plates. Yep.
Amalgamation plates. So they did a bunch of mercury stuff here.
Mercury, yep.
This is where they got their roughly 10,000 ounces. Was through this mill. So they processed a lot of material.
Absolutely, yep. Lots of material. And this mill was ran by a Pelton wheel with the water line coming down the valley over there.
Okay.
From the stream up above. Ran a Pelton wheel, and that's what generated the power to run the mill.
I think I saw the Venturi nozzle there at the end of that line.
Yeah. Yep.
That's cool. So they ran a Pelton wheel just to make the electricity to run the electric motors.
Yes.
Yeah, awesome. And where did all the tailings go? Are they all still here on the hillside somewhere?
Yeah, so you can kind of see the tiered dams over here in the field.
Oh yeah,
And
I
they-
see them. Yeah, the little.
Yep. And so they just let the slurry go on down the hill. It wasn't illegal then. No, environmental standards or anything. So
Yeah.
they got away with stuff like that. But,
So all the milled tailings are right down there still.
but when my grandfather got here in the beginning, he came through with a dozer and kind of an excavator, like an old excavator, and he excavated the old tailings, and that's the first thing that he ran through in the new mill that we have.
Oh, is that right?
Yeah.
So all the old tailings have already been reprocessed.
Yes, he reprocessed. That was the first thing that they did, and that's how they got enough money to finish the mill building.
Whoa, cool.
Yeah.
Do you know how much gold he got from reprocessing the tailings?
Oh, I don't know. Yeah,
Enough to get it going, right?
Probably like a couple hundred ounces of gold, So
Yeah,
good
reprocessed.
amount to finish the building.
Because these mills originally, even with the mercury plates and the stamp mills, they weren't very efficient. And so you lost a lot of gold either not getting captured by the mercury or not getting liberated by the stamp mills. And so a lot of these old tailings ponds still had a lot of gold that they were sitting there in a pile, and all they needed to do was send them through a ball mill or another crusher or something, liberate more. They probably captured a lot of mercury as well. And it was a great way to get gold and get some cash flow for these other projects without having to go underground. So there's a lot of, you'll hear that a lot throughout history of tailings piles being reprocessed 2, 3, 4 times. They would go through mercury, and then they go through cyanide, and then they get recyanided, and then they get crushed and recyanided. So think of them as a potential resource always. Didn't always work out that way, but there's a perfect example of your great-grandfather saying, hey, there's X amount of dollars sitting there in a pile, let's go run them through our mill.
Yep.
We are now down at the 200 level portal. It's right here where this culvert is, and they're working on getting this all dug out and reopened up. It's caved now, you can't access the workings, but the idea is if you can get through here to the underground workings, that 200 level we were on, you can come right into the mill buildings. I'll show you, I'll turn around. You got the bunkhouse up here, and you got a bunch of buildings down here that Josh is gonna walk us through, but they would come right out of the 200 level. They could come right over here into this building, and you can see these tracks, and then they had what's called the snow shed here, and the snow shed went all the way out to the mill building, which is right down there. You can just see the top of it, and the tracks of the snow shed came all the way out here and all the way back into the 200 level portal, so they could bring their ore right out here, track it all the way down to the mill. So Josh, a lot of these buildings were built by your great-grandfather, correct?
Yep, in 1915. All these buildings were built by my great-grandfather and his partner, which is called Mr. Fox.
Mr. Fox.
Mr. Fox was the investor, and my great-grandfather was the project manager.
Awesome, cool. And so you've got the portal here, you've got the blacksmith shop, I think.
Yeah,
Tell us about some of these buildings here real quick.
Yeah, so up here they had to create a lot of their own tools. So they had the blacksmith shop for all that sort of stuff, the little tweaks and of the little fine tuning of the equipment, So all that stuff got done in the blacksmith shop there. And then this was just the general shop for spare parts and hose fittings and just anything that the miners would need throughout the day of mining and milling, which could be a lot of inventory.
Yeah, right.
Yeah.
So
They tended to break a lot of stuff.
right. Yeah, exactly. So they need a good sized building for that. And then that building at the end there is the building that was like the mud room. That was like where all the miners started for their day. That's where they got all their slicks on and stuff, and all their equipment that they needed was housed in there.
Cool.
Yeah.
So you want to take a little tour of the mudroom miners building here. So these buildings are 100 years old.
Yeah.
Yeah.
Over, a little over, yeah.
And they put up with the Alaska winter just fine.
Yep, they do good with the heavily sloped ceilings, you know.
Oh yeah, it sheds the snow. That
Yeah.
makes sense.
Yeah, so this is all of our other clutter that we have in here right now.
Did you get a dry washer? That's awesome.
Yeah, yeah. Yeah, these were their spots where they got all their, you know, supplies that they, for the personal stuff up top, and this is where they got their boots on, their muddy stuff, and
This was like their lockers.
exactly
Minor lockers.
Yep, the minor
Wow.
lockers. Yep. And they could. This is the way out to the snow shed to connect to the mine, and so it was a really nice gig that they had going on.
Oh, cool.
I'll follow you. Go ahead.
Okay.
So even when the snow is 10 feet deep, you can get through here
Yep.
to get to the miner shed here, huh?
Yep.
Or the snow shed. Whoa, cool.
Yeah.
Check this out. So it just accesses right to where the
Wow.
rail is. And you can imagine, you know, snow and blowing and it's windy out here and stuff. And they can just kind of come into this little snow shed and the tracks are all covered and access the mine. And you never have to go outside once you get in this building.
Yeah, really a comfortable gig. Yeah.
That's cool. So we're walking our way down to the mill building. And is this the old dump or something where they just took a bunch of waste?
Yep. Yep. That's all underground rock. Yep.
And then laid rail down on top of it. And then we're going to the old mill building here. And there used to be a trestle that connected the rail to the mill building. It's since fallen down, but that's one of his big projects in the next couple of years is to connect that trestle back with the mill building. And their long-term goal really is to get the mine running again on the 200, be able to bring ore all the way into the mill building. And then they have a nice, really cool little old mill they're gonna get rerunning again. And then right over here, you can see just the classic mill building style. You bring the rock in the top and they use gravity and they just run the stuff down through the crushers and the gold amalgam would come out at the bottom. So we'll get in the mill building. We're gonna start at the very top here and we're gonna work our way down through the process.
You guys look like it's a story time.
Yeah, that's cool. I don't know.
Go for it. This actually looks pretty cool.
All right, cool. So we're up at the very top of that mill building, and right behind us is the ore hopper that they would dump the material in, and it will feed down right into this jaw crusher here. So you're looking up now, that's the little hole that the raw ore would get dumped into, and it'd come right down over that grizzly, and the fines would go down through the fine ore bin, and anything that made it down here would go through this jaw crusher. Looks like about a 10 by 16 or so. And once it crushed through this jaw, it would go right down through to the fine ore bin down below. And where'd you go, John? Your dad was telling us about this was like a fancy new jaw crusher back in the day. What's the story with this jaw crusher?
The theory is that it's supposed to not shake down the mill buildings. Because back in the day, all the mill buildings would get shaken down by the jaw crusher.
Okay.
So that the hydraulics used into the system, it's supposed to create less shaking while the jaw crusher is doing its thing.
Okay.
And it's done great over the years for us. So
The building's still here.
the building's still here.
Yeah. But this was like new technology back in the day.
Yeah, brand new technology.
It's got a bunch of like crazy springs and dampening stuff, and I don't know. It's like I've seen a lot of jaw crushers. I've never seen one like this before.
Yeah.
So it's cool that they made it so it doesn't bang and shake and rumble so much.
Right. Yeah.
But there's a lot of ore that's been put through this thing.
Lots of ore.
Yeah, lots of ore.
Lots of ore going through this. Yep.
So we saw the coarse ore bin. Here's the jaw crusher. Right below us is the fine ore bin, right?
Yep.
I think we can take a little peek. So we're looking down the fine ore bin now. And this, I think it's a 60-ton capacity, your dad was saying?
Yeah, 60-ton capacity.
So they could hold like 2 or 3 days worth of milling
Absolutely, yeah.
in this ore bin.
They could hold the top ore bin holds 40. This one holds 60, so it's 100-ton total capacity.
Oh,
wow.
They could run through the mill. Yep.
And this mill ran pretty much 24 hours a day.
Yep. 24/7.
Is that right?
Yep. Yep.
And so it's a 1 ton per hour mill.
Yeah.
So they're cranking through just 24 tons every day, and at an ounce ton, that's 24 ounces.
Yeah.
That's pretty good.
That's a good day. Yeah.
Well, let's go down below, and this feeds out into a ball mill. Is that correct?
Yep. It feeds the bottom of this ore bin is a nice feeding conveyor that feeds right into the ball mill at a consistent 1 ton per hour.
Cool. So we're taking a little shortcut on the way down. We're going to go visit the assay office here. And there's a lot of cool stuff in here. Haven't done some smelting and stuff myself. You got cupels and crucibles. Josh, tell us a little bit about what went on in here.
Yeah, so they the geologists in the mine would always take little chippings of where they're at to get a good sample, see if that is a development area or not. Whether they should keep drifting on the vein or should they stope up. So this is a good place to get a good assay.
Yeah, cool. So they would bring the chip sample in here, they'd crush it up, they'd melt it all down, and pour it in these cone molds, do their fancy magic stuff on it, and then they'd say, yeah, this ore had 1 ounce a ton, or half an ounce a ton, or 2 ounces a ton.
Yep.
Cool. And then right behind you, Harry, we saw this the other day. There's the old safe where they would keep the gold bullion, right?
Yep, that's where they keep the gold bullion, right in there.
So back in the day when they were mining in the 30s and 40s, you could only sell gold to the government. Is that correct?
Yeah, and you had to, as soon as you get it, you sold it. If you had any kind of stock inventory, it was big problems.
Really?
Yeah, you could have some serious jail time because of it. Yeah.
So did they have like a government buyer come around to all the mines and buy like once a week or whatever? They would. Oh man!
So if they caught you, it was a big deal. My dad would always ask his grandpa, my great grandpa, oh, you held some, right? And he goes, no way. If you got caught with that stuff, it's serious stuff. It's because at the time, the dollar was backed by gold, so they needed all the gold they can get.
Oh, I see.
Mm-hmm.
And so the safe held the gold for a week or whatever, and then the government would come by and load up all the gold, write you a check?
Yeah.
Is that how it worked?
About right, yeah.
And then you would get paid and the gold went down to Fort Knox or wherever it went.
Yeah, wherever it went.
Yeah. Okay. All right, let's talk about we'll focus on the milling stuff first, but then you got a lot of other cool stuff here behind us that we'll get.
Absolutely.
So this is the fine ore bin was right over here, correct?
Mm-hmm.
Okay,
Yep.
and then walk us through kind of what happened here with the rest of the equipment.
Yeah, sure. So this was the feeding conveyor, and this had a ratcheting technique over there where the conveyor would only move like this, tick, 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 and it would give a nice consistent feed from the ore bin to the ball mill, and that's exactly what they were looking for.
And this would come out from the jaw crusher. The fine ore bin was like 1 inch minus or 3/4 inch minus. Okay, so everything had to get to 3/4 inch minus to be fed into the ball mill.
Yep, exactly.
Gotcha.
Yep.
All right.
So this ball mill was originally only half the size. You can see how they added the extension later on. But when the mill was, like when I was referring to them running through the old tailings, up at the 200 level, but the ball mill was only half the size and they were only just having a half-ton throughput. But once they were able to produce enough, they ended up extending the ball mill to, get more production.
So they just stretched it out.
Yeah, they just added a whole nother side onto it, and got up to that 1 ton per hour.
Yeah, that's a lot cheaper than buying a whole new ball mill.
Yeah,
just
right.
Make your small one twice as big.
Let's make it twice as big. Yep.
So it'll feed into this. This is like a 3x6 Denver ball mill, and the ore would get crushed from 3/4 inch minus down to 30, 40, 50 mesh, somewhere in there.
Yeah.
And then after that, it would flow, and you ran a little bit of water in it, right?
Yep.
To flow the material through. And then right here at the end of the ball mill, they had, you can actually see in the ball mill. That's cool.
Yeah.
So I don't know, Harry, can you get?
Yeah, I'll get
see
in there.
And you film and I'll talk. So you're looking right in the discharge side of the ball mill now, and it would feed, the fine material would feed out of the ball mill, and it would go into this little rotary screen that you're seeing right on the left of your screen there. And the oversized material would stay in that screen and come out the end. The undersized would drop down into this tray, and then what would happen to it, Josh?
So originally we had the amalgamation place that sit right here,
But since then, we've replaced it with Jason's table here, and just to get away from the mercury side of things.
This is a 1 ton an hour table?
It's a 1 ton per hour table, so it all fits in series with all the other equipment here. Yeah, this is a fantastic table. We wouldn't want to have anything else running our ore that we get. You know, you work so hard to get your ore, you want a good concentration, so we wouldn't want any other table here.
Nice. You like the table. It's doing well for you.
Yeah, no, it's a fantastic table.
This one and the one up on the hill too, we'll see a little bit later.
Yeah.
But now your whole system is mercury-free, chemical-free. It's just water and gravity.
Absolutely.
And you can recover a really high percentage of the gold.
Absolutely, yeah.
Awesome. So it's not quite set up yet. You've got a little bit of a couple things to do.
Yep.
But eventually you'll trough that over to the table.
Yep.
And then the ore will run down the table. The gold will come out this side, and you'll recover the gold. But then the tailings will go into this rate classifier. And this was, again, before with the mercury amalgam plates, but also the shaker table. The tailings are going to go in here. And what does this rate classifier do?
It does the same as a spiral classifier. Just all it does is separate the big oversized and from the fines. So it would work in a motion kind of like this, with it raking the material up. And so everything that was oversized would eventually get itself raked up and then go back into the grinding circuit. But everything undersized would come, and there would be a nice flow with the movement that the material would flow up and over this ledge here, and then come down and make its way to the flotation cells.
Okay, cool. So the fine stuff is agitated, and anything that doesn't sink in this thing floats up with the water flow and down these troughs.
Yep.
Do you know about what this is set to?
I've heard that in this district that 85 mesh was the best.
85 mesh.
85 mesh. Yep.
So 85 mesh and minus would flow up and out here and down to flotation, and anything larger would sink, rake its way up, and get fed back into the ball mill.
Yep.
And just regrind until it could float up and out.
Exactly. Yep.
Now the cool thing to me about these classifiers, whether it's a spiral classifier or a rate classifier, is they actually work on the weight of the particle. And so if this is set to 85 or 100 mesh quartz that can float up and out of here, you have to get like a 500 mesh piece of gold to have the same weight to get floated up and out of the process. And so if you lose any gold from your system, it will sink down in this rate classifier, and it will stay in this system for a long time until it's captured or it's ground in the ball mill fine enough to float out. But with sulfides that are more dense than quartz, and with gold especially that's way more dense than quartz, it will stay in this system and give you multiple chances to capture it. But like you said earlier, if the stuff does float out of here without gravity concentration, it floats down onto the flotation cells right here behind us. And this was the last chance to catch the sulfides in the gold.
Yep. This was the last. This is just to get the super fine gold that was still yet to be recovered. The amalgamation would get 80%, but this would give you your last 20 or so. Last little bit, last super fine gold that the amalgamation wasn't able to get.
I have a very basic understanding of how these work. Can you tell us the fines would flow in with the water, and what happened in these things?
So there would be a influx of pine oil into it to get agitated with the material, and so whenever the material would get agitated, or the gold would get agitated with the pine oil, it would then float on the water, and then these paddles would then slowly paddle the bubbled up fine gold down and into these two basins that Jason is in.
I'm standing in.
Yeah.
I'm standing in the concentrates bit.
Yes. Yep. You're standing in the flotation concentrates.
Awesome.
Yeah.
And so it's kind of a Willy Wonka machine, really, because the stuff would get piped in, and then all these pulleys were going, and they run like a big fan underwater, right?
Yep.
And there's air that gets pumped down the shaft and out these little holes on the paddles and makes the frothing.
Yes.
And that's where the gold and pine oil combination would get attached to this bubble and it would float its way up to the top. And it's just this, I've seen videos of them and I've seen them in person a few times, where it's just like this gray, gross, nasty slime stuff. But it captures all the gold and the sulfides, and it just kind of scooches them off here into this trough.
Yes.
This is a 4-bank flotation cell. I've seen them also in the copper mines, lead zinc, where they would float the sulfides as well using different chemicals. Like one chemical would float the lead, one chemical would float the zinc, and you could separate your concentrates that way a little bit. Are there other metals in this district other than gold that you're chasing, or is it really just the gold and the iron sulfides for the gold value?
It was just the gold. In this district, it's just the gold. There's no other, other precious metals that we're after in this district.
Okay. So this was just gold cons. You'd get your free gold that you could smelt into bars. You'd get your concentrates that you probably sold to another smelter somewhere else.
Sent it out to a different outfit to get concentrated.
Yeah, this is pretty crazy.
Yeah. So you can see down there, the what happens? The slurry will come in here at the bottom, and the thing spins around like crazy and foams and froths. And then there's these, they're all connected via pipes, and it would go from one bank to the next, to the next, to the next, and all the gold and everything would float up to the top. And this little flapper here just goes around and paddles, flops it off, and then it comes down and is caught. Oh, this is different than I've seen, actually. So these 3 banks paddle the foam off, and it goes back into this cell. So this is the only cell that takes a final concentrate. These 3 feed back into that one, which is kind of cool. I've never seen it that way. Maybe that's how they're supposed to go. I don't know. But the ones I've seen, every cell has a chute that drains it off, but this all sends it back to the one.
Sends it back and it just splits
So it's
off.
got like 3 cells with a finishing cell.
Yeah, finishing cell. That's right.
cell.
One finishing cell.
Cool.
Yeah. And here in the next, year or two, you and your dad and your brothers are going to get this mill running again.
Yes.
That's the plan.
That's the plan. Yep.
Yeah.
Yep. We're super excited.
That's get a pretty good idea how big this building is.
Yeah, huge building.
And it actually takes a lot of maintenance to keep this thing standing. We got really harsh winters up here, lots of snow, lots of wind, stuff's always moving and wanting to fall over.
Who's calling me?
You're ringing.
Here's that amalgamation table, right, that they were using where the copper plates were on?
Yep. And we didn't want to throw it out because of historical value, but we wanted to keep it, out of reach from.
So it would have come out of the ball mill here, and they would have had smeared the mercury on those copper plates by hand.
Yep.
And then this is where they would swap them out.
Yep. And then it would just flow, discharge, and right into the classifier. Yep. And this was the big compressor that would feed the mine of all of its air. And so this pipe goes up and all the way down into the 200, 300, 400 workings that they were mining out of.
Wow.
Yeah, all came from just the building.
And I have seen lots of these in museums, and I've seen them at old mine sites, and you'll see, a flywheel laying in the woods somewhere, but this is a complete compressor that probably still produces air.
Yeah, absolutely. We start the engines every year just to, keep the lubrication going. But,
Do you?
yeah.
That's Chicago Pneumatic.
Does it say a year on it?
I'm looking. No, I don't see anything that looks like not unless they're using like a Julian date or something.
But this big diesel motor runs this big, huge, wide belt. Here's the tensioner for it, and it just runs this big, huge, single cylinder compressor, right?
Yep.
And it just rams air down that pipe. And what do we got here?
And this was the generator. This is what generated power for the mill, the camp, the mine, everything. Everything came from this generator here. And the engine for this generator is the same as the engine for the compressor.
It's a big old Caterpillar
Yeah,
diesel.
both of them are same engine to keep the parts
Yeah.
simple.
Parts compatibility.
Yeah, exactly. And this is the generator head.
Holy cow.
The shaft, it's huge.
It's like a 3-inch shaft.
Yeah.
And this was what made electricity for the whole place.
Yep. It's running electricity for the whole camp.
And this still works.
Yes.
It's
But
still,
well, it's not unsafe to generate power with.
sure. Yeah. It looks
But,
unsafe just to stand near it.
No, these old things, man. If the windings ever go bad, you can bring them into a motor shop. They'll rewire them just fine.
Yeah.
You could probably still get brushes for this thing.
Yeah, probably. But yeah, all the engines run. You know, just really well maintained stuff. You know.
I heard a story that if your brushes wear out, then you start getting a ring of fire.
Yep.
And the ring of fire, I think, comes from when the generators. So if you ever hear a ring of fire, that's where it comes from.
Yeah, that's my great grandfather would always tell us about the ring of fire. The ring of fire.
Really?
Yep. And this is what he was referring to. Is at the end of his life when he was running the mill, he would talk about the ring of fire.
The ring of fire.
Gotta be careful about the ring of fire.
Yeah.
Yeah.
That's really cool.
Yeah.
Just the amount of work these guys did.
Oh yeah.
I mean, the mining is one thing, but then the mill and the infrastructure, and you had a crew of 10 or 12 guys up here that had to be fed and housed and kept warm, and it's a whole little city.
Yeah.
A whole little town.
Yeah, huge project.
Yeah.
Big respect for those guys. Yeah.
Yeah, huge respect for those guys.
Well, I got to do it. Sorry.
Oh. Oh.
I think this was just put here because it's cool.
Yeah.
Well, that's our tour of the Gold Cord underground mine and mill. Josh, thank you so much for showing us around. This is an awesome place. It's so much history, so much going on here, and it's great that you and your dad are keeping it alive, and you're going to keep going and mining.
Yeah, I'm thankful that I get to share the information with the world like this. It's very cool.
Yeah, very cool. So thanks guys for watching. I hope you enjoyed the content. We'll see you on the next video.